Alright, in 3E we're determining transformations. We've previously done this by inspection, and that's not actually a big issue. You can absolutely do that, but if you are unsure, then using this algebraic method will, I suppose, always get it right. So there's no chance, well, there's a chance, but there's a very small chance of error in doing it this way. Basically what we're doing is saying, well, we've got a base equation, for instance here, 1 on x squared, a truncus, and then that's undergone some transformations to get this. Now, what we want to know is, what are those transformations? There are two ways that this question can be asked. You can have something like this, where you're trying to get back to this, okay? Or you can start with this and try to get to this. Now, we're going to look at two examples. One going in this direction, so from the transformations back to the original, and the other one is going to be from the original to the transformations. And there's, I suppose, one really big difference in that, and that's to do with rearranging the new equation. So we'll have a look at this as we go. Alright, so example 1, find the sequence of transformations which takes the graph of y equals 3 divided by x minus 1 squared plus 6 to the graph of y equals 1 divided by x squared. We want to undo the transformations that exist here. So for instance, by inspection, I can see I've moved my graph up 6 units, which means that somewhere in this I'm going to have to move it down 6 units. So step 1, rearrange the equation by transposing the terms outside of the equation. By that, I mean that I want to get this as close back to the original as I can. So for instance, I have plus 6 that exists outside of a 1 on x squared, and I've got a 3 that exists outside of that 1 on x squared. The x minus 1, that minus 1, directly affects the x, so I can't move it. It's going to stay there. So when I rearrange this, my first step is going to be to minus the 6, and then I'm going to divide by 3. Now, what I've done is I've created a scenario which previously would be what I've substituted in. This would be my x new value, and this would be my y new value. So this is what I've previously substituted in. So when I go to draw a flowchart for this, more to the point, if I go x new is equal to x minus 1, and y new is equal to 1/3 y minus 6. No, I'm not rearranging that, okay? So normally, previously, what I've done is I've gone, well, what does x equal? So I've rearranged it, x new equals x new plus 1 equals x, etc., etc. In this particular case, because I'm going from my transformed function to my original function, or my base function, I am not rearranging it. That is a big difference between the two scenarios. So from my transformed function to my base function, do not rearrange. So going straight to my coordinate points, I start with x, y. Now note my transformations, or note what happens first in each of these to x and y. Here I'm going to minus 1, and here I'm minus 6. So my first thing is that I'm going to translate 1 unit to the left and 6 units to the down. I then have this dilation of 1/3, so that's my next step. There's nothing else to do here, so that's not going to change, but I am going to divide by that 3. That gives me my x new and my y new. This makes sense because previously what I've done is I've read off x new is equal to x minus 1. That's what I have here. Y new is equal to y minus 6 divided by 3. That's what I have here. So this, I suppose, makes sense in what we've just done. Now, this basically just allows us to read straight off the transformations. So the first step we did was we moved it left 1 and down 6. So that's our first translation or transformation. And then we've got a dilation factor of 1/3. And because we're multiplying the y value, it's from the x-axis. So from the x-axis. This I'm putting down just so you can get it really clear. Note that when you change from transformations to the original function means no rearrangement in step 1. Okay, so up here in step 1, we do not rearrange this. In example 2, we're asked to find the sequence of transformations which takes us from an original or a base function of y equals x squared to the function of, there should be a y there, equals 5x minus 1 squared plus 6. Now I'm going to do one solution to this. There are multiple solutions to this question, or to any of these questions actually. This is maybe not the most straightforward, but it's definitely correct for what we're after. Our first step is the same as the previous step, or previous question, where we rearrange the equation by transposing terms outside of the equation. So anything outside of the x squared. In this particular case, the x portion is 5x minus 1. So we're going to move that 6, and that's about it. So I'll rewrite the equation, and then I'm going to minus 6 from both sides. And that's my rearranged. Now making my y value equal to y new minus 6, and etc. Now note here, this is my y is equal to y new minus 6, not y new like the previous question. Now the reason for this is because we're going from a base to a transformed. So we have to do the transformation here. So we're going to rearrange this and get what x new equals and what y new equals. So rearranging it, I'd get y new is equal to y plus 6, and x plus 1 is equal to 5x new, which means x new is equal to 1/5 of x plus 1. Now we're up to the flowchart. So we're looking at these two parts here. That's my y value, this is my x. The first thing I've done on both of these is to do a translation. So 1 unit right and 6 units up. So x plus 1 and x plus 6. My next step is then to do a dilation from the y-axis of 1/5. So it's affecting the x value. So 1/5 x plus 1 and y plus 6. That gives me my x new and my y new. Now I just take this information and I write it out, I suppose, fully. So we're going to write it out instead of just writing it as a flowchart. So we're moving 1 unit up. So translations are 1 unit up, 1 unit right, 6 units up, and then a dilation factor of 1/5 from the y-axis. Note, affecting the x values means from the y-axis. Again, because I'm changing from a base function to a transformation function, means that I do need to rearrange my x new and my y new, or these two functions up here. That's the two differences between them, and you really need to make a note in your rules book with regards to that, so you're really clear.